those two. I'm going to do those two problems with you guys today. And I hope you guys actually tried this beforehand, because me just showing you everything is not going to be very helpful for when you actually do it. So let's begin. Like yesterday, I am going to read the question, and then we're going to actually move on. All right. So this, we're going to start with word processor. Bessie is the cow working on an essay for her writing class. Since her handwriting is quite bad, she decides to type the essay using a word processor. The essay contains n words, 1 through 100, separated by spaces. Each word is between 1 and 15 characters long, inclusive, and consists only of upper or lowercase letters. According to the instructions for the assignment, the essay has to be formatted in a very specific way. Each line should contain no more than k characters, not counting spaces. Fortunately, Bessie's word processor can handle the requirement using the following strategy. If Bessie types a word and that word can't fit on the current line, put it on that line. Otherwise, put the word on the next line and continue adding to that line. Of course, consecutive words on the same line should still be separated by a single space. There should be no space at the end of any line. Unfortunately, Bessie's word processor just broke. Please help her format her essay properly. Input. The first line of input contains n and k. The next n words are separated by spaces, and basically, you have to format Bessie's essay correctly. So what are we, what is this problem basically asking? Basically, it's asking, you're given n amount of words, and you can have n amount of letters on a single line. And basically, if the word is too big, you have to go to the next line. I'm actually gonna share. We'll do this on a whiteboard. So basically, you're gonna have, I'm gonna say A, B, C, and D. You have these 4 words, let's say these are words. And each line can only have 2 characters. That means in line 1 and line 2 and yada, yada, yada. However, in the first line, the first character is going to be A. In that case, we only have 1 character, so we can add another one if the next one is 1, because 2 minus 1 is 1, obviously. And we see that B is also 1 character, so we can do it here. It becomes 2 characters. That means we know that 2 is the max, so we know that we have to go to the next line, right? But let's say I try to put C here. Then 2 plus 1 is going to be 3, which is greater than 2. So we know, oh, now C has to go into the next line, becomes 1. And we are on our final character D, we make this 2, and we put it here. So basically, that's the gist of the entire problem. What you're trying to do is you're given words, you have a limit, and you're trying to make sure you can put as much as you can before you go to the next line. All right. I'm hoping that you guys understood the problem. Now I'm going to move on to the coding part. So, oh, shoot, my bad. What we want right now is I formatted this ahead of time. The reason I'm using, if you see here, file reader, buffer reader, and print writer, compared to the scanner, is because it's faster. There's no other reason, it's just faster. So we know in it, we need to have an n and a k. So we're gonna make them static variables, n, k. N equals in the next int. Actually, since we're using a buffer reader, we cannot do that. We need to use a string tokenizer. Equals new string tokenizer dot read line parentheses, and n is gonna equal integer dot parse int s to the next. The reason you put integer dot parse int is because, as we know, it's a string tokenizer, not an integer tokenizer. So the line that it reads will be simply a string. And then we do the same thing, but instead for k instead of n. So you can just copy and paste that, honestly. And then what we need is something that holds all the words that the n words. So we're gonna make static string. Let's just go with a. And a equals new in dot read line. We don't need a string tokenizer for this one because we're just getting the entire line and we're not dividing it up. Split. And then we're going to test if this works. And if we run this, we get all the words. Voila. And the reason we don't get any spaces is because of the split that we put in. And since we initialized everything, we should now start putting everything in. For this, we're actually going to use a string builder. So what a string builder is basically a string, but much more efficient to use. So string builder, SB plus new builder. And what's the first thing we're going to do? The first thing we're going to do is put in the first word. So why are we putting the first word in? Because we know no matter what, the first word is going to go in the first line, whether we like it or not. So sb.append. Append is the function that we use to put in things into the string builder. And then we do a at 0. And then now we're going to use a for loop actually. So within this for loop, what we're trying to accomplish is the fact that we got to check if this goes beyond the count, then go to the next line. If not, add it to that. And we have to make sure there's no spaces at the end. So we're actually going to use that to our advantage. We're going to make this temporary variable called t at a0.length. Why are we starting with a at length 0? Because we're going to start checking on the first line if it goes over or not. And since the first line holds a of 0, we want t to be the length. So we can subtract from t 4. And t, you add a at I, dot length, which is going to be the next letter. And then we check if t is greater, is less than or equal to k being the maximum amount of characters that can be in a line, then SB, the append, space. We're just adding a space. This condition exists to check if you can actually put a word in, so you don't put an extra space at the end. And we're going to write else. Else, that means if t is greater than k, SB that append \n. So what \n does is it's an escape sequence that basically moves to the next line if printed. So within the SB, it's going to be one entire large string. However, because of the \n, it'll go to the next line and then start printing and continuing. And we're going to make t equal to I, because that's the new amount of characters that are in that line as of this current moment. And after both conditioner checked, sb.append a at I, not length. And why are we not putting a continue here? Because this is only if this does not happen, and that's the one that's really checking if you add a space or not. And the space determines basically if something's going behind it or not. And then we just do out dot ln sb that to string. And if we output print this, you should get something like such. You see, hello, my name is Bessie. and this is my essay. And it seems to work. Does anyone have any questions? Any questions, anybody? Okay, then I'm going to go over what I did one more time before I move on to the next problem. So we made static variables n and k, n being the number of words and k being the maximum amount of characters that can be in one line. String array A is holding all those words that we want to check. And then we make a new string tokenizer, like I said before, to get n and k, because we're using a buffered reader, and we cannot use n.extent because this is not a scanner. And then we make A in that read line, and we split it by the spaces, so we don't count the spaces when we're actually doing the calculations. And we check to see if that worked. And then we made the string builder to put in everything. Basically, it's our answer. And then sp.append, we add the first one into the first line, because whether we like it or not, the first line will always hold the first word. And then we make this temporary variable called t equal to a at 0 length, because that's the amount of characters that are existing within that line. And then we run a for loop, basically checking the entirety of a of I. And then we add the new length that we're getting. The new word is going to have a new length. We add that to that temporary variable of t, and we check, is t less than or equal to t? The reason we check that is because if it's greater than, that means we cannot add that word into that line, and we have to go to the new line. However, if the t is less than or equal to k, you can add it to that line. That's why we put a space, because we want to ensure that there is no extra spaces at the end. And then if t is greater than k in this instance, then sp.append \n, which means go to the next line when printing this. It's an escape sequence, and you make t equal to a at I.length, because the new line has that many characters, the characters of the string. And then we just append a of I, because if it comes to this point, that means this happened. And yeah, we have to add it one way or the other. And then we just print it out. And once we do, there we go. It just ends like that. All right. I'm assuming everyone understood that based on the fact that there are no new messages that came. Now we're going to move on to Photoshoot. Once again, I will read the question out loud, and then we will go into what it means. Farmer John is lining up his cows, numbered 1 through N for a photo shoot. Farmer John initially planned for the I've cow from the left to be the cow numbered A of I, and wrote down the permutation A1, A2, all the way to AN on a sheet of paper. Unfortunately, that paper was recently stolen by Farmer No. Luckily, it might be possible for Farmer John to recover the permutation that he originally wrote down. Before the sheet was stolen, Bessie recorded the sequence B1, B2, all the way to B minus 1. That satisfies B of I equals A of I plus A of I plus 1 for each 1 to n. Based on Bessie's information, help Farmer John restore the lexicographically minimum permutation. That just means the smallest values. Permutation A that could have produced B. A permutation is lexicographically smaller than a permutation if for some j, x equal I, for all I is less than j and x being less than y. It is guaranteed that there's at least one such A that exists. And the input is going to give you n, and then it's going to give you n minus 1 integers, basically b, and you have to basically print out what the permutation was. And we see here, you share. We see here 5, 4, 6, 6, 7, and 6. The reason there's only 4 characters, like I said before, it only holds n minus 1 ones, because each one is added of A of I plus A of I plus 1. So of course it's going to be one smaller. So we have 1, 2, 3, 4, 5. We know that the first two added together is going to be 4. Next to 6. Next to 7. Next to 6. So knowing this, we have to basically put in the values that would satisfy this. And we know that each number has to be different than the other. So for 4, I can put 2, 2. It has to be 1, starting from 1. So either one of them has to be 1. So let's say I put 1 in the beginning. That means this has to be 3. That means the next one would have to be 3. So that obviously does not work. So we're going to start with 3. Move on to 1. That means this can be 5. 5 plus what is 7? 2. 2 plus what is 4? 2 plus 4 is 6. So we get the new order 3, 1, 5, 2, 4. As we see here, the first two become 4. The next two become 6. Next two become 7. And next two become 6. That way we know that B is correct. And yeah, that's basically the problem. Everything. Does anyone have any specific questions about the problem? All right. I'm assuming you guys all understood the problem. And I'm going to start. And we see here, I use buffered reader once again for the sake of efficiency. And we hope that to achieve the fact to find those new permutations. So knowing this, what do we need? We need n, because that's the starting place of any USACO problem, static int n, because we know that's the amount of numbers we have. Next, we're going to make a static int array, actually, called b. Why do I call it b? Because in the problem, it states b holds a of I plus what, yada, yada, yada. So we're going to initialize these two first. N is equal to int in that read line. The reason I can do read line instead of string tokenizer here is because read line, if you read the line, there's only one thing there. And then we're going to initialize a new int plus 1. Not a, b. I'm so used to writing a. B because n minus 1 because it adds everything. So, and then we're going to make a string tokenizer because we need to get that entire line and put it into b. And iser in that read line. And then we're going to put a for loop right underneath it, actually, to actually fill that in, that a, not a, b. Ooh. 0, I is less than n minus 1, I plus plus. B of I is equal to st by next token. That way we know that B is full properly, and we're going to test that. I see my problem. Parse int. I forgot to cast it like that. Oh, that println arrays that to string b. And we're going to check if b is actually working the way we intend. And as we see here, yes, it is. Now, we're going to make this new thing called a tree map. So what is a tree map? It's basically, a map is basically, there's a key and there's a value. The key, if you reference the key, the value will be printed out. And the thing about a tree map is that it does not, like a hash set, it doesn't take in repeats. So we're going to actually make that hash set and not hash set, tree map. And as I do this, you'll start to understand more why the tree map is actually useful. And since there's a key and a value, we need to initialize what it is. I'm going to call that m. And we're going to actually make a static string num. Because what num will do is basically it'll hold all the num is going to hold the everything, basically the answer. And then we're gonna have to initialize tree map and new tree map integer. And then everything is initialized. Now we're gonna start solving. So for the answer, we're gonna make an array list because array list, you can change the length and it's comfortable like that. Integer new and equals new. Copy and paste because it's faster. And after you get this array list, we're also going to make a string builder, which will become clear later on why we will. That string builder. And now we're going to make a for loop that goes through the entirety of a map. Because we want to make sure everything is working. Oh, I forgot to do something. I forgot to fill in map up here. That's my bad. We're actually going to fill it in with values from B actually. Int I equals 1 is less than n, not n, B at 0 plus plus int j minus I meant to write B, that's a habit. And if I is equal to j, then m dot put I comma j. If you remember before, is basically there was the condition on the problem that states I and j yada yada yada. It's complicated, and there's also the fact that these are new values, new places. So it'll become much more clear once what happens. For int k m dot key set. Key set is just we're doing the same thing as an array, but instead we're using a map. So we want to put key set and equals new array list integer because we got to check if this works. And then we add k, the first one, obviously. Add k, k being the number. And then you also add, what do you get m k, get k, because k is going to be that number, the value. And since it's going to be that value instead of the key, it's going to be a different thing right after it. I meant to write add, not get. And in this case of we have 5, 4, 6, 7, 6. And the map, what it's going to hold is basically the value 3 is going to be holding 1. So we added 3 and then we added 1. And then we add another for loop within it. Int I equals 1, I is less than n minus 1 because there's only n minus 1 in B, I plus plus. And then we're gonna get x and y into x, and start get at I, and then int y being a of I minus x. These being two different values, I meant b of I keep writing a. And then if answer that contains, basically if the answer array contains what we already have, basically an already established number, or if it's less than 1, because it cannot be, because the number starts at 1, and since we cannot have repeats, we just break. And because that's when we know, oh, stop. Else and start add y. We can add, that means we know, oh, this next one is the number that we're trying to add. And then we go and start add y. And then we put a little statement on the bottom. If and start size equal n. So why are we chasing, like checking if equals n? We know the original permutation variable a has to have the size of n. And the reason this works is because we made this break statement. If the permutation does not work, that means there's the same number again, or there's some number below one, with including 0 and such. That means ants will not have the length of n, and that means that permutation does not work. And it says lexicographically smallest, right? We start at the smallest number, 1, 3, or whatever it is. So we know guaranteed that it will be the smallest. And then we write SB that append, and it's like get 0. And then we write for int I equals 1 less than n start size. Instead of n start size, even though that is comfortable, you can just write n, since we check that n's size is n. And sp dot append, you put a space. You want to put a space. And the thing about string builder is that you can append multiple times in the same line, which makes it very comfortable. Right? And start get I. And that way it keeps on adding and adding and adding. And then at one point, you're gonna have to break, because that means you found your answer. So once you break, it seems like I put the break in the wrong area. And then out that println. Did I put this outside? Yep, yes I did. I'm going to put it in here. Has to be all within everything. We don't put the break there, we put the break here inside the if. And then once everything runs out the println sb.to string. What I did was just very confusing. I will go over it right after. And we see here 31524. It works. So before I go over the entire thing, does anyone have any specific questions for me? I did do a very rough job on this one. So I'm asking once again, does anyone have any questions? Please type it into the chat. You don't need to turn on your mic. All right. The I and J part. All right. So what I and J does, not just to clarify, this is not a hash set, it's a tree map. So what the I and J was, it's you're basically making a key and a value. So for each occurrence, basically, we subtracted it from the first one and we made that value the key. We subtracted I, as you see here, like I being like I, that we use the for loop. We got that. We subtracted from the first one to ensure we get like a individual key value. And then we check if I and J are different. That means we can make I a key value and J the value of the key. I hope that was helpful. That was kind of confusing. It'll make more sense. I'm just going to go over the entire thing. Okay, thank you. It seems you got it. I'm going to go over the entire thing if no one has any more questions. All right. So let's organize this a bit. We made a few static things. This thing we kind of didn't need. Don't miss that. We made n to hold the number n, basically how many numbers we should get in the permutation. We made b being the kind of permutation that we got, because it's the added value of a of I plus a of I plus 1. And then we made a tree map, excuse me, to keep track of everything. So n, read line, be n minus 1, because it's a of I plus a of I plus 1. That means the last one will not have a pair next to it, so it's just 2, 2, 2, 2 like that. So we made a tree map, integer, integer, put everything into b of I. We checked if j and I, we made if they work as key values, put it in. Then we made a string builder and the answer array list to, for the sake of sanity, because we need to continuously add, and string builder is not basically the best thing if you want to clear and such. So ans equals new array list. You add k being the first key and the first value, in this case 3 and then 1. So basically what the key and value really do is just, hey, there was this number, I subtracted this, so this and this will equal the number in B. The first this being the key and the value. The key and value added together will become B. That's just for keeping track, like I said. And now we move on to the section of X and Y. X will be ans.get at I. Basically, what value is there at this point? And Y will be B of I minus X. Basically, comparing these two like we just did for I and J. It's the same logic. And let's say we find I, and we see that I is equal to another number with an answer. That doesn't work because a permutation means everything has to be unique. And then we have the case where y is less than 1. That can be possible because we start counting from 1. So we break out of this formula. We stop to ensure that this permutation does not happen. But let's say it does happen. Then we just add 1. So what do we then check? We then check if answer.size is equal to n to make sure that the permutation actually worked. Because if the permutation did not work, that means it would have break in the middle and it would not equal n at one point. And then we just add that all into a string builder to print very neatly. And then we break, since we found our answer already, we don't need to do it any more times, and we just print it out. And then we get this. All right. Any questions? Today we did go over Word, the word processor, and photo. I believe photo was a little bit harder to understand and do. I'm hoping you guys all understood what I was saying, and I'm hoping everyone actually did the problem beforehand and is fine being like, oh, this is a new way, or being like, oh, that's why my code didn't work. Any questions? Just privately message me through chat. If you have any questions, I will wait another minute before ending. Yes, this I believe this recording will be posted. Any other questions? All right. If there are no other questions, I will be ending class today. Remember, guys, please do the problems beforehand. If you didn't, that's kind of unfortunate, but please do it ahead of time so you guys actually learn how to actually wire your brain and such, because it'll help you a lot. Individual practice, I do believe it will be helpful. And until tomorrow, goodbye and have a good evening.
Thank you, Sean.
Thank you, Tay. Bye.